Yes.
Okay, perfect. Thank you again. And yes, thank you, Martin. What you see here is the Diabetes Research Institute. I am based at the Diabetes Research Institute, which is one of the institutes at the University of Miami. I'm also part of the faculty at the Department of Biochemistry and Molecular Biology. And I'd love to share with you some important information that has emerged from our recent clinical trial of umbilical cord-derived mesenchymal stem cells for COVID-19 ARDS. So I believe that many of you are familiar with this disease at this point, and I hope you'll have a chance to take a look at our manuscript that has just been published on stem cells translational medicine. I'm gonna go through a quick description of the problem. So we all know the disaster that this pandemic is creating. The infection from this virus can lead to full-blown COVID-19, and in the most severe cases, it can lead to acute respiratory distress syndrome. So if we look at the lungs very closely, we will see that those that get infected with the virus and develop COVID-19 can still handle the gas exchange to some extent, but when there is a fluid seeping in that really fills up the cavities inside the alveoli, the gas exchange is extremely blocked, extremely inhibited. So we're talking about the most severe cases of COVID-19, which thankfully represent a minority of the hospitalized cases, but still the most problematic to treat. So here you see with an even closer look, gas exchange in healthy occurs with no issues, but after infections, things change, and they change very quickly. So when the virus infects the lung, it stimulates immune cells, including resident macrophages, that become activated. And as they become activated, they release inflammatory cytokines. These inflammatory cytokines call in additional immune cells. And at this point, immune responses can take two directions. If an immune response is well balanced, things can resolve quickly, but that requires an efficient and well balanced immune system. Not everyone has such immune system. In certain individuals, the responses can be overactive, hyperinflammatory. And in this case, they enter a vicious cycle of hyperinflammation that can lead to what we call a cytokine storm, where all of these inflammatory cytokines start damaging the tissue. So at this point, progression to COVID-19 ARDS can take place. It happens in part because there is loss of epithelium here and coagulation and fibrin deposition inside the blood vessels as well as outside. The virus affects the epithelium of the alveoli and the endothelium of the blood vessels. So the situation becomes remarkably inflamed very quickly. At that point, there is alveolar damage, fibrin deposition, and what we call an immunothrombosis. A fluid can seep in from the damaged vessels and it starts filling the alveoli. And this is when we observe clinically overt acute respiratory distress syndrome. And obviously not all the alveoli are impacted at the same time. So some patients can still handle and recover spontaneously from this condition, but mortality is still very high. So the mortality, when we started this study, the mortality for acute respiratory distress syndrome was reported to be 52%. And of course, it would be nice to prevent many of these deaths. So as I said, there seems to be a cytokine storm centrally involved in the progression to ARDS. And this cytokine storm is something that we really want to inhibit. If we could inhibit this, we could potentially we could lower the severity of the disease. But we need to catch the patients at the appropriate time. The cytokine storm is progressive, but it is not present in the entirety of the disease natural history, of course. So we were studying mesenchymal stem cells. They're also called mesenchymal stromal cells. And more recently, Arnold Kaplan has proposed yet another name, medicinal signaling cells, which is very relevant. That because these cells exert functions that are largely immunomodulatory and could be highly beneficial in COVID-19 ARDS. So they're immunomodulatory in the sense that they can inhibit certain immune cells from releasing inflammatory cytokines, for example. They're directly anti-inflammatory, so they turn off inflammation with a plethora of mechanisms. And they have paracrine trophic effects, which means that they can stimulate tissues such as even the lung epithelium or the endothelium to regenerate, so to grow back and heal. They're also anti-fibrotic, which would be a good advantage in the long term for the recovery of the function of those lungs. They're actively fibrinolytic. At least certain mesenchymal stem cells are fibrinolytic, which means they could dissolve. And they also release antimicrobial molecules. So all of these functions could be highly beneficial in COVID-19 ARDS. Ultimately, we hypothesized that these cells could inhibit the cytokine storm and decrease inflammation. So we utilized mesenchymal stem cells, and these in particular derive from the umbilical cord of a healthy pregnancy. So the cells derive from a healthy pregnancy after a healthy term delivery. They derive from an umbilical cord, and in particular, the subepithelial region of an umbilical cord. And we grow the cells to generate cultures that we call UC-MSC, umbilical cord derived mesenchymal stem cells. So the objective of our study, phase 1/2A clinical trial, was to determine safety and explore efficacy of these umbilical cord derived mesenchymal stem cells in subjects with COVID-19 ARDS. So we first expanded the cells at the Diabetes Research Institute CGMP facility, and following a protocol that has been established here,